of what's expected and what's going to happen. So we're doing angles. So we're moving on from segments. So let's just brainstorm for a second. What are some things you know about angles, just in general? Like words on it. What do you think? They're measured in degrees. Like, what do you know? What kind of angles are these?
Adjacent.
Partner or linear or long plane.
Vertical.
Vertical. What do you know about vertical angles?
They're the same.
They're equal. What do you know about these two?
Linear pair.
They're a linear pair, so they're supplementary, which means they add to 180. What about this guy, this picture?
90 degrees. Oh.
Complementary. And then what about this one? What's happening there?
It's the bi-middle point.
It's acute.
Not midpoint, it's bisecting. Okay. So, essentially, we just went over all the reasons that you can use in a proof for angles. You already know these things. We're just going to give them fancy names now, okay? But you already know all of these properties of angles. So, this is on your little cheat sheet, the blue one, for your angles. You can still add, subtract, multiply with your angle measures. Reflexive, symmetric, transitive. Those all hold true. Okay, now we have ones that are specific just to angles. And the first one is the definition of congruence. It's just like the same thing for segments, where you just took off the squiggles or put it on. It's the same thing with an angle. You guys see here? I have no squiggle. And here, I have the squiggle. Definition of congruence. Same thing. What's next? What does a bisector do? Cuts it in half. So what two angles would now be equal because angle LKJ is being bisected?
LKM.
Yep. Okay, what's next on our list? Complementary means the sum's 90. So if you have a picture like this on your proof, or like this, you can automatically assume what? They're complementary. What do those pictures tell you? Those, they add to 180. What else do we call that when they're connected and add to 180? Dylan, are you with me?
No, let me grab my phone.
Thank you. I think I should start taking everyone's phone in here. Ooh, I know.
Yeah.
I think I might have to. Okay, what does perpendicular mean? Right angles, how many angles are formed? 4. What do you guys know about a right angle?
90 degrees.
90 degrees.
So if I have two right angles, what do I already know about both of them? If one's 90 and the other one's 90.
Oh, they're
Congruent.
They're congruent. Or yeah, they add to 180. This stuff, I promise, it's not as complicated as you make it. It's very obvious things. Angle addition. So this is just like segment addition, but with an angle. Do we agree we have this big angle here?
Yeah.
And then I can split it up into this angle and this one. That's angle addition. We don't know that they might be, but they might not be. Anyone else? Okay. Let's see. Vertical angles. What do you guys know about vertical angles?
They're congruent.
They're congruent. Okay. That's it. They're the same. We already talked about complementary angles and supplementary. Ooh, this is a good one. It says angle A is complementary to angle B, and B is complementary to C. So what do we know about A and C?
And they are equal.
Yeah. Right? If A and B have to add to 90, and B and C have to add to 90, what can I take away from both sides? Angle A plus angle B equals 90. And angle B plus angle C equals 90. What can I subtract from both equations? B, right? So then you're left with just angle A and angle C. Okay, this is finally your notes. things that we can actually do together. It says find the measure of each numbered angle and then state the theorem why we can do what we did. So what kind of angles do we have on this first example? What do we know about them? They're supplementary.
Linear pair.
They're a linear pair. So you're literally going to say they're supplementary. You can throw the word theorem on there, or you can just put supplementary. I don't really care if you know whether that's a theorem or not. But we just know supplementary angles add to what?
180.
180. So now what's an equation I can write?
180.
X plus 10
4x plus
3x
28.
plus 18 equals
Yep. This guy plus this guy equals 180. You write it how you want.
180.
How many x's do I have? 4 plus 28 equals 180. 180 minus 28.
152.
And if we divide out,
Hmm.
152 divided by 4. 38. Okay. Now make sure we answer the question. We need to find the angle measure, so we got to plug back in. For angle 1, what's 38 plus 10? 48. So then angle 2 would have to be. You guys agree?
Yes.
Yep. Done.
So don't you do like the
Nope, not for this part. Okay, on this second one, what do we know about? They are a linear pair.
They're complementary.
Which ones are complementary?
4 and 5.
How do you know they're complementary?
They are right angle.
Yeah, it's a right angle. So you're going to put they're complementary, so we're write the word complementary, or definition of complementary, however you want to write it. And then what would my equation be?
6x minus 8 equals 3.
Perfect. Six x equals 108. That would be what? X equals 18. That's what I got. Is that what you got? 18?
Yep.
All right. Now we got to find our angle measures. 3 is easy. What's 3? 3 would be
31. Wait, no.
90, right? That's a right angle. That has to be a right angle.
31.
4 is 31?
Yeah.
I agree.
My
Mode angle 5B.
15.
Okay, so part of your assignment is just doing these. You're going to tell me why you know what you know. So supplementary or complementary, and then you're going to find the angles. Not too bad. Let's see how we do with an angle proof, okay? Let's just see how this goes.
No, this is
I think you guys are going to like these more than segment proofs, because you've already done the hard stuff. Okay, it says angle 1 and angle 2 are supplementary. What does that mean? Okay, so right now I know these two angles add to 180.
Yep.
And we're also given 2 and 3 add to 180. So now what do we already know about angles 1 and 3?
They're equal.
They're the same, right? Okay, so now we're going to see if we can prove it. Okay, so it says angle 1 and 2 are supplementary and 2 and 3 are supplementary. What's my reason? Given. Always your given. So now, why can I say that 1 plus 2 equals 180?
Addition.
Because they are supplementary.
Because they're supplementary. So I'm going to say definition of supplementary. So you're looking for patterns.
Congruent.
So now why can I say 1 and 2 is equal to 2 plus 3?
Because they
Definition.
congruent.
That's not going to be my reason though. But look, they're both equal to what?
180.
180. So when they're
They substitute.
substitution or transitive, either one. I'm going to use transitive, but you can use substitution.
Oh, I know what I'm doing.
Okay, what happened from 3 to 4? What happened to my?
Your substitutions. No.
Oh, I lied. Where I'm skipping a step. Okay, what? When the same thing equals itself, what is that called? Reflexive. My bad, kids. I was just getting excited.
Where's the word subtract?
Okay, now I lied. How do you jump from 3 to 5? What happened to our angle 2 on both sides?
Subtract.
We subtracted it.
Subtract.
So a subtraction property. And then what's happening from 5 to 6? We're just putting the squiggle on top, so definition of congruence. So transitive is when you have two things that are equal to the same thing. So now you can set them equal to each other.
Wouldn't that be substitution?
Substitution's more when you just replace like one thing. So like plugging in like angle 1 and putting angle 3 there instead. Really, they're kind of the same thing, so I use them loosely. And it's okay if you use them loosely too. All right. How'd that feel?
Are you gonna test on all like the
You have algebraic proof, a segment proof, and an angle proof on your test.
Is there a test before the end of the quarter?
I'm hoping to put it on quarter 2. So
Yeah.
it's on Friday. I don't think you want to start quarter 2 with a test grade. It's going to take forever to bring it up.
But I want to keep my quarter one.
Actually, I want to keep my
Yeah.
quarter 1 grade.
Yeah.
is,
If you started with the test grade, it almost like.
But see, if you, let's say you bomb this test, then it's going to take you all quarter of quarter 2 to bring it up.
That's
Yeah,
alright.
destroy their quarter one.
That means you'll have more
Well,
time
either
to
way, it's
fix it.
destroying one of your grades.
That means you'll have more
So
time
can we
to fix
decide?
it.
Yeah, I'd rather
Can we
keep
decide
it
what
with
quarter
the
goes
one.
in? Yeah, depending on our grade.
No, everyone
Yeah,
has to do the
actually,
same.
no,
We have a chance to fix it.
How about we think about it? Okay, you guys see if you can fill in the blanks.
No one touch me.
Just try, or just try to reason through what's happening, and we'll talk about it together. Okay. Well.
Can you fill out the last one?
We have some days to figure it out. Use your picture, label your picture.
Wait.
Wait, so if it bisect or then
Not
you
equal.
suddenly go to this, is that transitive?
Because
Is that definition?
No. What word did they use? Like, why did I just explain what's happening? You don't have to give it a special name.
yeah, we just learned.
Mm-hmm. Mm-hmm.
Definition of vertical.
Well, you say angle 1 and 3 are vertical. though. Yeah, that's kind of a weird one. Okay, so ADC is being cut in half by DB. So why do I know angle 1 is congruent to angle 2? What'd you guys say?
Because of bias.
Yeah, it's being bisected, so you can write just bisector or definition of an angle bisector. Now next they're saying definition of vertical angles. What are my only vertical angles here?
1, 3.
1 and 3. So this one's kind of weird. You're going to write angle 1 and angle 3 are vertical angles. It's kind of a redundant step.
And then you just reflex.
Because now why is 3 congruent to 1?
The definition of perpendicular.
So close.
Reflexive.
No. What kind of angles are 1 and 3? They're vertical, so you're repeating yourself again. So you're going to say definition of vertical angles.
Why is that a step?
So if I were to wrote this proof, I wouldn't have included this extra step, but since I was trying to use examples from your book, I just left it. I think you can get rid of this top step, this third one, and just go straight to 4. You say 3 is congruent to 1. Transitive property, what do you guys think that's going to be for your statement?
Measure of 3 is congruent to measure of 2.
Because what are they both equal to?
1.
So now they're equal? Yep. Remember the symmetric property does?
Just flips it.
Flips it. So now do you guys see how it matches what we're trying to prove? Close? Kind of got it?
I got it.
Oh,
thank you.
Not even close? Okay.
I'm gonna add some.
You got one left. We're just jumping right in. It says angle ABE and DBC are right angles. I want to prove that this guy right here and EBC, this guy here, are congruent.
Both 90 degrees. Or no, they're both
Equal.
45.
Do we know what their measure is?
I'm just gonna leave.
No.
Shoot.
Okay, let's write-
Half of 90.
They're part of 90.
This could be done in like 2-3 steps.
It's pretty close, yeah. So do you guys see where our right angles are? Here's a right angle.
There are 3 right angles.
There's 2 right angles. And here's a right angle. What angle is in both of those right angles?
DBE.
Do you guys agree that DBE is in both of those right angles?
Yes.
No, wouldn't it make sense? The other part of your right angle would have to be congruent. If you take away the same part from each side. That kind of makes sense? Okay, let's see if we can prove it. Okay, what's my first step going to be? The givens, right? We should all say that in unison since it's always the same thing. Angle A, B, E. Okay, so we now set our given. Anyone have an idea where we should go?
ABE equals 90. DBE, DBC equals 90.
Let's try it. Let's see if that fits well. So all we're saying is that they equal 90 degrees. So I'm going to say angle ABE equals 90, and angle DBC equals 90. What's my reason for that?
Visual.
Visual? Wait, well, what do you guys know about right angles? What's their measure?
Right.
It's just a definition of a right angle. They equal 90 degrees. Don't overthink it, I promise. Okay. Now what could we do? I want to show their parts. Two of their parts are equal.
ABE equals DBC. No.
ABE equals DBC. Can I say that this angle is equal to this angle?
Yeah.
Why?
Because they're equal to 90.
Okay, so let's say it.
90. 90.
What do you mean if it's like?
You could say substitution.
Is there a difference between substitution and transit?
So substitutions would be just like replace one thing for something else, and transit would say one into a whole.
My mind is the only mind that thinks just like my mind.
Yeah, but your mind is.
Okay, now what would make sense to write?
ABD equals DBC.
No.
A.
What makes up angle ABE?
You did. Let's say
What makes up angle ABD?
AB. ABD plus. Wait.
Half
AB plus
half
D.
ABE.
What?
I don't know.
So what two angles make up ABE?
ABD.
Alright, so we're gonna write that. So we're gonna write angle ABE equals angle ABD plus angle DBE. What is that called?
Definition of angle.
I heard it. Angle
Angle.
addition. Nailed it. Can I do the same thing for angle DBC? What makes up angle DBC? Yeah.
DBE.
Can't see my picture. EBC. What's my reason for that?
Angle addition.
Angle addition.
So. ABE.
Okay, now what can we do? You guys can do this.
Remove DBE. Right.
So what do I know about ABE and DBC?
Equal.
They're equal, so now what can I do with these two things?
They're equal.
So set them equal to each other.
One party.
Set them equal to each other. Oh boy.
Oh.
Jeez.
Wait, did I say the wrong thing at the beginning?
What's that?
Yes.
We're almost done. We're almost done.
All of this just to tell you that ABD is equal to ABC.
Now what can you subtract from both sides?
Ooh.
What matches?
DB.
So get rid of it. Subtract it away.
Do you have to do this school stuff?
I don't know. What is it on our? What are we trying to prove? Are they congruent or just equal? So yep, we gotta do the squiggle step.
Let me see. This just seems unnecessary.
I think it's kind of fun. Once you get the hang of it, it's kind of enjoyable.
Damn, man.
Oh my.
Definition of congruence. Give yourself a high five.
Not good.
No, we could really do
The most annoying one?
Yeah. Best high five we've ever seen someone.
Not done yet.
Alright.
Done.
I think this really helped.
Did this help? Oh, good.
Yeah.
So if you are still super duper lost, you gotta come see